now. Okay, because on the left hand side, square root and square disappear, and square root 4 is 2, but don't forget plus or minus 2. Finally, x is equal 7 plus or minus 2. Entonces 7 plus 2 is 9. And 7 minus 2 is 5. And that's it? No. No, because you need to checking both solutions into the original equation. The original, okay. And the original is logarithm base 4 of 9 minus 7 plus logarithm of base 4, 9 minus 7 should be 1. I claim this statement. For 9, no? First, and after for 5. And 9 minus 7 is 2. Logarithm of base 4 of 2 plus logarithm base 4 of 2. And now, one more time, I apply the property number 5. Because I see addition, I condensing logarithm of base 4 of 2 times 2 is 4. Es obvio que es 1 using the property number 2. And remember the property number 2 says the logarithm of any base of the argument when the number inside the argument is the same as 1. In this case, the answer, the number inside the argument is 4, que is exactly coincident with the base, entonces 1. So we prove 9 is perfect. Let me try 5. So again, a substitution in the original equation 5. I can see it doesn't work because 5 minus 7 is negative 2, and negative 2 is totally illegal, it's completely out of the domain. So logarithm of the negative number is impossible, it's undefined, to be undefined. Therefore, this is wrong, this is right. Nice. And this is wrong. Wrong, therefore, 5 doesn't work. The only solution that we have in this equation is 9. Any question? Solution set is 9. Any question? Question? Come on, come on, come on, come on. No. Okay, Rosemary. Well, we move on. This was a question 17, no? 17 in the review package. Now 18. 18 now. Okay, 18. 18 is, okay, let me try 18. Is log of the x plus 3 is equal 1 minus log of x. Again, solve for x. See, no specification of the base here is because it's 10. So default, you need to know que es 10. Entonces now the procedure is the same. We condensing, pero to condensing the logarithm, I need to move every logarithm to the same side. Same side. I move this log, que is minus, to the left hand side. Now ready to condense in only one. And one more time we apply the property number 5. Entonces es multiplication. Multiplication what? X times x plus 3. And this is now the argument of the our logarithm. Now ready to convert to exponential. Because in exponential form, you see more clear. So now the base is 10, you know. The exponent is 1, que es invisible, que es this one, equal the rest. The rest is x times x plus 3. In this moment, I suppose that we have a quadratic equation. X squared plus 3x. Let me write in standard. X squared plus 3x minus 10 equal to 0. Okay, in this case, this quadratic equation I suppose we can do that by factorization. Because two numbers can multiply each other, give me 10, and somehow give me 5 when you addition or subtraction is 5 and 2. What different sign? 5 positive and 2 is negative. So we have x plus 5 equals 0. Solution is negative 5. And x minus 2 equal to 0. Solution is 2. It's obvious that the solution que es negative doesn't work. This is completely wrong. Because when you plug it in here, in the original negative 5, no, doesn't work. So I need to prove que 2 is good. Plugging in the original, logarithm of 2 plus 3 should be equal, I claim that 1 minus logarithm of 2. Okay, substitution 2 here and here. 2 plus 3 is 5. So I propose you, again, similar to the solution, I move minus logarithm of 2 to the right hand side. Like a plus. Now you apply one more time the property 5, you condensing. Es addition, es multiplication, entonces logaritmo of 5 times 2 gets 10. And one more time we have the property number 2. Let me recall again. Property number 2 says logarithm of the any base of the same number and the argument is 1. In our specific example, es common logarithm. Entonces, I suppose que default the base is 10 of the number inside the argument is also 10. Therefore, it's clear that the answer is 1. Therefore, x equal to is right answer. Now, the solution set for this equation is just 2. Solution set. Positive 2. Any question, guys? Question, come on. This is okay, no question, Rosemary. Only Rosemary participate. Rosemary said no. Janelle is okay. Caroline is okay. Annie is okay. Michelle, everyone follow me? Do you understand this? It's easy, no? Or it's too hard? Nahel Amaro, no question. Okay. Marta Chivas. Okay, Marta. Very good for you. Okay. Let's move on to the last one. The last one is number 19. 19. Okay, 19 is 19. 19. Is logarithm of 2x plus 1 equal 1 plus logarithm of x minus 2. It's similar, no? It's similar to the previous, except in the previous we have minus here, we have plus. The same procedure. I move the logarithm in the right hand side to the left because I want to condensing and only one. Minus logarithm of x minus 2 equal 1. But in this case you apply the property number 6 because it's minus. So since minus division. So the expression is 2x plus 1 in the top, the positive part, and the negative part in the bottom. Everything is the argument for the logarithm function, equal 1. Now conversion to exponential. It's the same. When you try to manipulate the equation in order to group in the logarithm of the left or the right, so together, put together in the same sign, you apply the property whatever, 5, 6, or 7, and after we convert to exponential. Remember, the base is 10. The base is 10. Because you need to know default, okay, when there is no specification, any number in the base here, It's because default is 10. It's equal, the exponent is 1, and 1 is invisible. Not necessary to write. It's equal the rest, que es 2x plus 1, divided by x minus 2. Entonces we have now linear equation, no quadratic. Linear equation. You apply cross multiplication, maybe. So you multiply 10 times x minus 2 is equal to x plus 1 times 1, que stay the same. You apply distributive property, 10x minus 20 equal to x plus 1. Entonces, 10x minus 2x is equal, 1 stay here, plus 20, I move to the right, positive. Here we combine is 8x equal 21, divided by a both sides, 21 over 8. And then this weird number into the original equation. Everyone follow me? Do you understand very well the algebra? Now substitution. Remember, mandatory checking in the logarithmic equation. In the exponential, no. In the logarithm, always. So you need to prove somehow the logarithm of 2 times x, que es 21 over 8, should be equal 1 plus logarithm of 21 over 8 minus 2. I need to prove this. Okay, let's do it. Well, in this case, I can see we can simplification a little bit. Look, 2 and 8 divided by 2 is 1, divided by 2 is 4. Actually, is logarithm of 21 over 4 plus 1. Well, let's do in the arithmetic of the argument, que es 21. Let me try to do separately here. 21 over 4 plus 1, que 1 is 4 over 4. So you try to express everything using the common denominator. Least common denominator 4 is 25 over 4. Okay, entonces 81. I erase that part. And the argument is 25 over 4. 1 plus 1 plus logarithm of 21 over 8 minus 2. They're doing the arithmetic part of the fraction, that is always complicated separately here. Minus 2 is 16 over 8, no? Entonces 21 minus 16 is 5, no? Let me check it out with the calculator. 21 minus 16 is 5. 21 minus 16 F5, yeah, F5. 5 over 8. I replace this by 5 over 8. How I continue the proof of this statement? Well, I propose you similar idea for the solution. I bring a second logarithm to the left. It's logarithm of 25 over 4 minus logarithm of 5 over 8 should be 1. Let me to prove this. Now again, we apply the property 6 to condensing this in only one logarithm, get logarithm of. When we have 25 over 4 in the top and 5 over 8 in the bottom, should be 1. Now division fraction, 25 over 5, and flip it, equal 8 over 5. Okay, it's the classical division. You copy the top division, exactly the same, and flip it the second fraction. Now you can see You can simplification a little bit. That part divided by 5 1, divided by 5 5, because 5 25 5 5 times 5 times 5, sorry. And 4 divided by 4 is 1 is 2. And 5 times 2 is 10. Again, we have the same situation. True. For the reason of the property number 2, no? And the answer, this is perfect. 21 over 8 is weird, is no nice, however, it's work perfect. Any question? Any question? And remember, let me write here. Test number 4 is to 22. Both guys, on paper and online. On paper, I send. And by the way, there are some students that send me back the answer. Not a lot of, but some students. And final test, que es no mandatory, is due April 27, que is the last day. Okay, so you want to improve, no mandatory. Let me spend the rest of the time some problem of the final review. By the way, the final is easy. It's easy because it's multiple choice. You have time, no, to do. However, you need to select A, B, C, D. And multiple choice. Any question, guys? Everything is clear. All right, I want to hear opinions. Everything is clear. Clear, confusing. Ruth is clear. Gabriel is clear. Okay, super. No problem. I suppose que you pass this class. I suppose, no? So, mandatory, you have to obey in this last moment. I don't want distraction. I don't want some people sick. Some people have family problem. No family problem. No. Okay, let's come back into the whiteboard. Let me try to, okay, not here. Let me try to bring the review for the final. Okay, the first page at least. Do you see very well or no? Oh, let me see. Do you see very well or no? Okay, I want to copy. Look, the first question say K4 power. This is number 1. Minus 9K squared. I forgot something, guys. I forgot. Before that, do you want can I do for you again some problem of the review package or no? You feel strong in the review package, or do you want can I redo again for you one specific question before I start review for the final? Come on. Remember, the review package contains 19 questions. I feel strong. Okay. This is my first question. It's obvious that this is equation the quadratic. A polynomial, right? A polynomial, degree 4. We expect 4 solution. Quadratic in 4. And this is the typical equation que you solving using U substitution, no? U is equal K squared. You take always the smaller. How do you know it's quadratic from? The clue is clear. We have 2 exponents, 4 and 2. This is twice. So we can manipulate in order to express it like a quadratic equation. But in this case, it's not quadratic, it's degree 4. It's polynomial equation. Okay. Pero I transform it using U substitution. This is 18. This is minus U. 9u, and this is u squared. I suppose you remember very well this because we started at the beginning doing that problem, no? Now, yeah, the factorization in this case, we have quadratic equation, no? Quadratic equation, there are several ways for solving. In this case, I realize that the best way is by factorization because 6 and 3, 6 times 3 is 18, 6 plus 3 is 9. Negative of. Therefore, u minus 6 is equal to 0. And u minus 3 equal to 0. Therefore, u is 3. But this is not the answer because this is u value. I need k value, que is the original variable. But we almost finished because I know the relationship connecting this variable, que is this. Therefore, this is equivalent to say that k squared is equal to 6 or 3. Now you have in that moment to separate quadratic equation, but the easy quadratic equation can you solve it by square root method. Entonces k alone is equal plus or minus radical 6, and k alone is equal plus or minus radical 3. This is exactly we expect. Remember, the degree of this is 4, degree 4, polynomial equation, degree 4. We get 4 solution, que es plus or minus 6, plus or minus 3, que I suppose que is this answer. And you select the option B. Any question? Any question? No? No question? No. Good. Okay. Let me erase. But I erase only that part. Oof. Okay. The final review is the people who doing the final. Yes, Rube, if you planning, don't take the final. You can leave if you want. Okay? You don't care that part. Okay. No. If you want to stay, stay. Remember, the final is not mandatory and the activity related. No problema. The activity related, connecting with the final, is not necessary to take. Thank you. You too, Ruth. Okay. Let's do it number 2. Number 2 is similar. Number 2 is, we see 2y plus 1 is square plus 9, 2y plus 1 plus 14 equal to 6. Again, we have in front equation quadratic in front because we have one expression here. Look, 2y minus 1. Okay, by the way, degree is 1, so the exponent is 1, and another case 2y plus 1 is exactly the same but degree 2. So the relationship between the exponent is twice. Nice. Therefore, we can apply the idea for the quadratic in front, and the idea for the quadratic in front is do u substitution. U equal to y plus 1. And you copy 0 is equal 14 plus something. This is u, and 9u, and this is u squared. And this is our new quadratic equation que somehow, you know, not 100%, but somehow is equivalent to the original. But this is easier. By factorization is u 7 and 2, no? 7 times 2 es 14, 7 plus 2 es 9, plus. Entonces u plus 7 equals 0, u is equal to -7, u plus 2 is 0, u is equal to -2. Is the answer? No, of course no. I need to find the y value. Solving this. Solve for y. Solve for y is easy because I take, one more time, this expression que connecting u and y. I'm plugging in. Suppose u -7. And -7 is equal to u plus 1. Or another possibility is -2 is equal to y plus 1. And you solve for y. Both equations, that, by the way, are linear equations. So you move -7 stay here, -1 is equal to y, and -7 and -1 is -8, divided by 2 both sides, and -4. -4 is y. Okay, y. No y, 4, carajo. This is 4. -4. Okay, now the second is similar. -2 minus 1 is equal to y. This is -3 equal to y. Divided by 2, both sides. -3/2 is the second answer. Is equal to y. So the solution is -4 and -3/2, like the option C. Any question? All right, let me see. How many students stay in the classroom? I know a lot of students stay in the classroom. Any question on number 2, guys? All right, let me ask curiosity. No mandatory answer me. For example, Rube, you planning take the final or no? Rube. A ver, who planning? Marta, Gabriel, Ashley, Katy, Tessie, Yulisa, Rosemary, Janelli. Katy, raise your hand. Okay. Caroline, Annie, Michelle, Delilah, Anayeli Santos, Bridget Ortega. Yeah, Bridget, yes. Okay, you're planning. Okay. Graciela Colón. Juan López. Okay, this is the idea que normally in the math department in Hunter Campus create, because Hunter Campus, the math department, understand that this class is hard. So college algebra always is hard. College algebra is always hard. So are smart, take advantage to improve. You're great. Okay? I don't know, so you have A, you don't need to improve nothing. But the majority of the students suppose que you get B, but B is not good for you. Take the final. Suppose que you fail the final, no problem. Stay the same B. Okay, let's move on to number 3. So you have no question. Guys, don't hesitate to ask me any question. This is a review, and we are doing some problems that maybe you don't remember very well, no? Or you remember. It's a finite community, everything together from the beginning. Okay. Number 3. Well, number 3 immediately, identification, que es radical equations. sea, es equation que contain radical. Square root 2x plus 12, pero 12 is outside the radical, is equal x plus 8. Okay, I copy. Remember, in this equation is mandatory checking. It's similar to the logarithmic you need to check in. And the radical, yes. The reason is clear. Because logarithm don't allow negative number or zero. And radical is also picky function que don't allow negative number. Bueno, si es negative es imaginary, entonces no inside the solution, que I suppose que es real number. But zero, yes, accept zero and radical. So this is their restriction in the function. Therefore, you isolate the radical. Then you move 12 to the other side. So we have x plus 8 minus 12 and negative 4. X minus 4. Okay, let me copy. So far, my equation is manipulated like that. And remember, the fantastic idea for eliminate any radical is a square, both sides. When you square, we have 2x equal, you foil here, actually it's the multiplication x minus 4 times 7, because it's a square. You foil first, outer minus 4x, inner minus 4x. It's no coincidence, they're always the same when they are twin brothers, no? Plus 16. Okay, so in this moment we have one quadratic equation. Of course, we need to express it in standard form. Entonces 2x, little by little, x squared minus ax plus 16. Okay, I propose you this guy stay in the right hand side and move 2x to the left, minus 2x, and here is equal to 0. Okay, so we have 0 is equal x squared minus 10x plus 16. Okay, look, again, it's possible doing by factorization because the combination is, wow, the combination is xx, a and 2, no? A and 2, a times 2, 16, a minus, or plus 2, sorry, is 10, minus both, negative both. Now, one solution is x equal a, no? So x minus a equals 0, another solution. And that's it. No, I need to check it. You see in the multiple choice, we have one option that contains both. However, I need to check it. Check it where? In the original. You check it in the original equation. Okay, and the original equation is this. Check it for 8. So first of all, replace x for 8. 2 times a plus 12 outside the radical should be equal a plus 8. 2 times 8, 16. Square root 16 is 4. And 4 a plus 8. A plus 8 is 16. This is the statement. It's true. It's obvious. It's true. Therefore, A is good answer. Let me try to verification to x equal to the square root 2 times 2 plus 12 outside should be 2 plus a. 2 times 2 is 4, square root 4 is 2, no? So 2 times 2 is 4. Should be 10 because a was 10. And this is 2 plus 12 is equal to 10. You get the contradiction because 14 no is equal to 10. It's totally false statement. That means that 2 doesn't work and the only solution that we have is B. Any question? Any question? No. Good. Well, let's do one more and stop, and we continue Wednesday with the famous review package. Because the last thing that we covered, that's let me erase the board completely. Again, I want to attach the PDF. Okay, review for the final. Good. But now the second page. Second page. Oh, look at that second page. Second page now is, look, we have exponential equation. Question number 4 is 3 to the minus x 1/27. Okay, this is the kind of exponential equation that you can manipulate both sides. It's a regular, no complicated that you need to apply logarithm on both sides. No. In this case, because I know que 27 is 3 to the cube, no? The problem is that this 27 is in the bottom, therefore we have 3 to the minus 3. Do you see that? Let's do it step by step. Look. You replace. Now flip it. Okay, in this crucial moment, we have two exponential functions. The base is the same, therefore the exponent is the same, therefore minus x is equal to minus 3. But if you multiply everything or divide everything, that doesn't matter, by negative 1. X is equal to 3. And you need to check it, no? It's nice, always is nice. The answer is B. Any question? One more, that's it. I promise. The last one. No, two more. No, one more. One more because I need to reserve some question for the Wednesday, no? And number 5 is super easy. Look, it's e to the x equal to 3. It's obvious that it's impossible manipulating that way. No, impossible because the base is e. And you cannot express the 3 using the base e. No. Entonces yo apply logarithm. But what kind of logarithm you apply? Why? Because okay, when you apply natural, it's the most convenient. Both sides. I need to know that property, que es the property number 3. Que es property number 3 in general, I write like that. Logarithm of the any base of the one exponential is equal to x. It's like a logarithmic and the exponential cancel out each other. When the base is the same. See, the base is different, no. Entonces, basically, natural logarithm is just x. Unbelievable, but true. And x is equal natural logarithm of 3. And this is the final answer. This is the exact answer. But when I go to the multiple choice, I see decimal. It's because I suppose that they want the approximate answer using the calculator. I put I put natural logarithm of 3. Close the parenthesis, press enter. The answer is 1.1.0 A6 122289. And they want two decimal place. I can see their approximation, any choice is two decimal place. So you round to the two decimal place, I can see that the next digit is 8. Now you increasing 0.9 plus 1 is 1 time. So this is approximately rounded. que es the option C. Any question, any question, any question. No problem. No problem. Okay, entonces I propose you stop. Because I need